That's actually matter.
M times D.
Yeah, it's not a fraction.
That's
I wish they would have found a better way to denote. Like, I get why it's denoted that way, it's just confusing for me.
I don't know how else you would denote it, I guess.
I don't know, I have to think about it.
Okay,
D to the same times.
so we turn 2.10 in. It helps to have this on. So what we're going to do is we're going to discuss the understanding checks first before we start working on the study guide. Y'all voted to not take the test today, right, Mona? Mona, you awake? Okay. So y'all voted not to take the test today and just let the 9 weeks test be the test. So we need to work on the study guide and review packet, but we need to also go over some of the understanding check questions that we've had issues with. So, I'm just going to skip the objectives. So, 1 or 2, any of these that we are looking at our answers going, I don't know why I missed this one.
Yeah.
Which one?
1 and 2.
Whew. What'd you put?
A for both.
Okay.
I had D for 1 and D for 2.
Okay, so A, and you said D and B. Okay. So, first off, Mona, when I look at D, what is the slope of D?
-7.
Slope, the rate of change is -7? These would be things we need to take note on. On D, the slope is 3/4, right? 3/4 times M times X minus X1 plus Y1. However, what is the slope supposed to be according to the problem? -3/4. So now you gotta pay attention to those negatives, they matter. Right? Now, clearly it is not A, because you got it wrong, right? Do you know why it's not A?
No. Probably because the plus sign, but I thought it would be because it'd be -7, but it in -7, so it'd be +7.
So that's the equation, right? Remember, one of the things that we discovered or talked about in the groups was that means that the X sign is always changing, but the Y sign is always staying the same based on whatever point it is. You can also substitute, just straight substitute those values in. This would have told you right away, X minus 16, cool, plus a -7. How do we add a negative? What's a simpler way to show adding a negative?
Subtracting.
Mm-hmm. Substitute into the equation and pay attention to those kinds of things. That would have made it much easier. Okay? Now, Mona, you picked B, right? For number 2? You were so close. B is perfectly correct as the point slope form of a line. But what did number 2 ask for?
Slope intercept.
Slope intercept. But then, McKay, you put y equals 12x plus 19. But is 19 the y-intercept? In order to have a y-intercept, the x value had to be what?
0.
0. So, what you could have done is exactly what you started with, Mona. Start with that point slope form. Right? But you have to recognize that that is not slope intercept. So I just have to simplify it. If you distribute, you get 12x minus 60. And then -60 plus 19 is -41.
I didn't think that would work.
Why would it not? These are things that we need to be writing down if we got these things wrong so that we can learn from our mistakes and grow.
That is not my pencil.
Alright? So, that was a perfect recognition from you, Mona, of hey, that's a point and that's a slope, so I'm going to start with point slope. It's just, we have to realize, I want slope intercept, hey, McKay. What's that thing in your left ear? Yeah. Does that make sense? It's something we could hopefully get right in the future? Okay. So we just need to recognize and pay attention to what is being asked, right? McKay noticed slope-intercept, and so he tried to do that. Mona noticed that I have a point and a slope, so she did that right. We just have to, and here's something I want you to recognize. If you had just said, hey, I'm given a point, I'm given a slope, so I'm starting with slope-intercept, or point slope, or I'm creating point slope, you would have gotten credit off of the rubric for stuff like that. However, if you just circle this answer with no justification, you're automatically at a -1. Justify your response. Explain why that's what you're thinking. Similar thing with number 1. Some people got the wrong answer, but they still got credit because they explained why that's what they were putting. The justification honestly helps you. It means that it's not just right or wrong, that you can show me that you understand something about that problem. Numbers, oh, never mind, I'm not even going to ask. Number 3, we're talking about this one.
Number 3
Holy crap.
it was.
You want to know what so many people did, McKay? I know Caroline's not here, but she does the same thing. Donovan's the only one who used the slope formula correctly.
Wow.
Only one.
Credit to him.
Right? But that's also why I keep telling y'all to stop trying to use the slope formula. The slope formula is something that students mess up all the time. Because they mix that up with
It's D.
the distance formula. It's not D either.
It was not D. I circled D. That was wrong.
The crap.
They mix it up with that one. They mix it up with the midpoint formula. There's a whole bunch of formulas with x1 and y1 and x2 and y2, aren't there?
I didn't know that until just now. Wow.
And this is not all of them. This is just some of them. This is why students mess this up all the time.
Wow.
So instead of using that slope formula, what do we always know about slope? What is the first way that you learn how to calculate slope?
Rise divided by run.
There you go.
Starting point.
And what's the mathematical representation that you could create?
I tried a table, it did not work.
What do you mean it didn't work?
Apparently, I got C.
The answer is A, right?
About to talk about it.
It has to have that.
Now, McKay, you did start with the tables. I remember that. Did you remind yourself rise divided by run, though? Did you write that anywhere there?
Nope.
Yeah, because that would have helped you. Because if I'm looking for rise, am I going to look at my x variable or am I going to look at my y variable? So, we got differing opinions. Remember, this is rising. Is that an x direction or a y direction?
Y direction.
Braden seems pretty confident still. What do you think? Okay.
For what? I don't know.
Rising, is it y or is it x?
I don't know. Yes and Y.
I stopped myself right as you asked and said his name. I was like,
What do you think, Alan?
why is the rise?
For rising, it's vertical, right? So, if I'm rising, how much is the y changing? What are we doing to go from 3 to 96?
93.
Which means, right, so delta y is how we say the change in y, but rise is the change in y. So the run must be my x. How much are we changing for the x? Plus 5.
So it is A.
Okay. Now, does that make sense though, McKay? Did you write down notes about that so that you can hopefully use that in the future instead of trying to use a slope formula that we're messing up all the time? Because I don't go over this for my health. I know this stuff. Spent years and years studying it.
Jeez.
I just want you to understand, like, it's not like, oh man, Mr. Kinney just learned this all in a year. No, I've gotten really good at this over the years. Where it's hard to understand. that we know the correct slope, and I will say this, on number 4, if you made a mistake on number 3, I read with you on number 4, so you may have gotten some credit but had the completely wrong answer because of what you put for number 3. So I read with some of that, but I will point this out. Even if you have the wrong slope, there is one answer up here you should automatically eliminate since we want slope-intercept form. A. That's not slope-intercept, is it? That would be a correct point-slope form, but not slope-intercept.
Fair enough.
We got to notice that our y-intercept is 3. And you can do stuff as simple as this. Hey, b is 3, m equals 93/5, and write out y equals mx plus b. Do you think that tells me that you understand what the correct slope-intercept form is?
Yes.
Yeah. I'm looking more for any level of understanding. That you understand what we mean when we say slope-intercept. If you would even just said, hey, slope-intercept y equals mx plus b, you would earn points on the rubric instead of a -1. Those are things that you can show me, hey, Mr. Kenny, I know something about this.
I got a 5, but I got it wrong.
Probably based on the wrong slope.
Mm-hmm.
What'd you put for your slope?
He said, 5, no, 5, 93.
5 divided by 93.
Mm-hmm.
And you put b.
Mm-hmm.
And you put some justification with b.
Mm-hmm.
And that's the thing, like, I read with your mistakes, but you gotta have some justification, and it's gotta make sense, and so I read with you. I'm not trying to punish you, I'm trying to give you credit when you understand things, but you gotta show me that you understand it. If you just circle the wrong answer, you're out of luck.
You told me I was incorrect, but correct.
Yeah, based on number 3.
Yeah.
So, that's how you can do it. I will also say this. You can make a table. You can also make a graph for slope. Rise divided by run is probably the most simple that way. And I know this would be, it would suck to go by 1s to 96, but you can do 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, right? And that will at least give you some reference to go off of. All right, I'm starting at 0, 3. 1, 2, 3, 4, 5. By 5, I'm at 96. Okay, so I rose 93. I ran to the right 5. Like, even that would have helped you realize I'm going up and I'm going to the right. So 1, it's a positive slope. Has to be A or C. And I'm going up way more than I'm going to the right. So it had to be 93 divided by 5. This is what I mean when, like, I say use mathematical representations. Y'all keep trying to use these slope formulas, these algebraic ones, when like a table or a graph, that's way more powerful. Helps you see things way more easily.
Number 5 caught me off guard, that's what I want to ask.
How what?
For, it says constant ratio, so it's adding, obviously.
Mm-mm.
No?
What do you do with ratios?
Multiply.
That would make it okay.
Mm.
So what were we thinking for that one?
I put A. You put A, I put D.
I put D.
Okay?
I feel like, though.
Guessing it's B or C.
Probably.
I feel like, though,
But
the look of it.
I want you to think about this. If you're saying that 3 is the constant ratio, well, first off, why'd you pick 3?
Sounded smart.
Man, I can pick numbers too. 82, that sounds real smart.
Mm-hmm.
No. Like, there has to be a reason.
I'm just saying the 3 and the y-intercept and picked it.
Okay, so I want you to think about that. And that's what I was assuming you thought. But 3 and the y-intercept is a starting point. That's not a constant ratio. Isn't the constant ratio a rate of change?
Yes.
So why would you pick a starting point for the rate of change? Heck, when you get down here, you could have gotten the correct answer just by knowing, hey, the starting point's 3.
Mm.
Like, you know what I mean? Like,
I'm guessing it's C then.
It ain't D.
Isn't the starting point 3?
Mm-hmm.
So look up here, what's the only answer that number 5 could be?
B.
Starting point of 3, constantly multiplying by 2.
Mm.
These are things called logic. That's not like,
Oh, so the answer was hidden in the next question.
oh yeah,
Ah.
super big. Super big, it's there.
Big brain moment.
Not gonna
Okay.
lie.
Now at the same time, what'd you say, McKay?
So not gonna lie. When I seen constant radio,
Ratio? I don't have constant radios, but you do you.
sorry, I'm dyslexic.
Not dyslexia. Dyslexia, you mix the letters up. You don't just invent your own letter.
It's a little slow.
I bet I got Tourette's.
That was funny. Inappropriate, but funny. Alright, what were you gonna say? When you saw constant ratio, what?
Freaked out, didn't know what it was.
That's weird, because
Oh. It's on the board somewhere.
sure is. Where did it go?
Like, where'd it go?
You don't call it common ratio, just call it R.
Oh, I called it R. Or constant factors, right? Geometric sequences, exponential functions, multiplicative rates of change
You
called
said
common ratios or constant factors.
You said common ratios. I know what you're talking about. Constant. Never heard that word in my life.
There it is. Okay.
Same thing. I'm sorry, I didn't realize I switched it on you.
I have a low vocabulary.
Yep, it's a common ratio, constant ratio, same exact thing.
Still reading
So
on
no-
third grade level.
But like as soon as you see the word ratio, you should have focused on that and said, hey, I'm repeatedly multiplying. Right?
Yeah, that's why I didn't do any
More importantly, McKay, right here, you see where it says what?
exponential
So if it's an exponential curve, what are you repeatedly doing?
multiplier.
So why are you letting this one word throw you off when you have ratio, exponential curve? And if you weren't sure about that one word, you could have asked. Now, what I do want to point out is we need to be able to find that constant ratio without using something like number 6. If it had been free response, you would have been boned. We don't want that, right? So how could I have found that b equals 2 without using this equation down here?
Genuinely, I'm not sure because the reason I went with the answer that I got wrong was because it was an exponential curve, and that's what I put was that it was the run, and then the 96 was the rise
But
at the time.
rise and run are linear ideas, additive rates of change. Is there any other mathematical representation that might help me be able to see this?
Algebraic,
Well, that's what we're trying to create.
tabular.
He's trying. He's trying.
Is that not right?
I
Graphical.
mean, yeah, 0 and 3, and we just need to recognize we're jumping to 5 and 96. I saw some people try to do that next thing, but what I want is the constant ratio that allows me to get in between there. So do I know what I'm multiplying by to get to here?
Nope.
Wait, so I can just do times r?
Yep.
Are we allowed to write on this now?
Yes, it's yours.
Okay. Because I'm steady writing. I'm like, wait a second. Should I ask?
No, go for it.
Alright.
Hold on, I'm undrawing.
Well, I'm going to go ahead and write big brain, or I wrote big brain and pointed to both the 2's. Because that was big brain, and you got that one in there.
Using a brain is a beautiful thing.
Using the
Now
brain
when
and
you
being
got one
confident
like
about it's even better.
Yeah. I mean, learning how it works is the best option, but using your brain to just think about it analytically is
Analytically.
next level.
What's that word mean?
I've never heard that vocabulary word before. I lie, I heard it in 7th grade, but still.
What vocabulary word?
Analytic. I can't even say it.
Analytically.
Analytical.
I'm still on a third grade level.
Let's fix that, because
It's
I
not.
believe you're a junior.
Yep.
Yep.
He's still kind of going through his
So-
dyslexicness.
I want to talk about this though. What can we do from here to get that b equals 2?
R5 or 5R.
Now, when I see multiplication like that, I think repeated addition.
Nice.
Thank you, sir.
It was
heard
trash
that.
at that point.
I heard that. I knew that was Swish. Alright.
Swish.
5. What's it called? Raised to the R.
So I'm multiplying by 5 a far number of times.
Raised to, I don't know.
He's tried, but he's. I'm not.
You're trying to just come up with something though.
It's
Okay,
exponential.
it's easier to think about the fact of what am I starting at?
3.
What am I doing to that 3?
Multiply it.
What am I multiplying it by?
Or
R.
5 times.
Right.
Or
See,
with the
instead of
exponent
it,
of
like
5.
we're just trying to abstractly throw crap together instead of say, hey, what am I starting with? What am I doing?
Oh.
Starting with 3, I'm multiplying by R 5 times. It's not random. It's not this confusing thing. It's actually very plainly, hey, what is happening? And it's after I multiply 3 by R 5 times, what do I get to?
Equals 96.
And I saw a lot of people correctly not divide by 3 here, but recognize, okay, so we have some kind of constant ratio of 32, but we need to recognize that that's 5 of those constant ratios to give me 32. So what do I now need to do?
Fifth root.
A 5th root, right? So raised to the 1/5, a 5th root there. 5, or when you raise power to a power, you multiply the powers, so that's what gives me a 1 for the exponent.
I made my pencil just.
And so, what is the 5th root of 32? I'm okay with using a calculator if it's
2.
Well, yeah, we did know the answer, I guess. It's fair.
You're welcome. Good math.
Yep,
Third grade coming at you.
that was very analytical. That was a good job.
Third grade coming at you.
Okay, so, but yeah, these are the things that we need to recognize that,
Oh wow. What the heck?
what?
With the orange, you did it multiple times. Oh, that's
Brown.
No, it is. It's the other one.
But I do want you to recognize these kinds of things. It's not designed to be hard. It's not things that you can't do. You can do them. Just gotta think for a little bit more. Now, this is really important. I need everyone's attention on this. Ignoring 7 and 8. Number 9. In the long run, which function will be greater, f of x or g of x?
I said f of x. I said g of x.
What did you say, Brady?
G of x,
Why g of x?
because it's, increasing faster.
How do you know g of x is increasing faster? Like when I look right here, g of 1 is only 3, but or f of 1 is 5. So how do you know g is changing faster?
Because it's constantly multiplying.
If it's exponential, right? It's a multiplicative rate of change. That is, while it's not faster at what we see, is definitely going to keep multiplying and rise more quickly than a line that is just kind of meandering, is the way I would say it. Right? It's just going.
Okay then.
But we need to recognize exponential functions in general are going to grow more quickly than linear functions, pretty much every single day of the week. Do we need to go over the equations for these two? Because I felt like that was an issue I saw.
It was an issue. It's just.
I fixed it.
What'd you put?
F of x equals 1 plus 4x minus 1. But I don't think it's minus 1 because you circled it with a big question mark. So not minus 1.
Well, it felt like you were trying to use point slope of sorts, like that, which would have made a little bit more sense. However, this one that we're starting with,
Yeah.
that's the what?
Y
That hurt.
and
Y.
intercept.
That one, notice the x value is 0, so you don't need that.
Yeah, I was looking at the 1.
You're looking at the what?
The 1. I just seen the 1.
Yeah, but that's the one that you started with, right? That's the y, not the x.
Huh.
But again, I would point out that it is slope intercept, so you could have done y equals mx plus b.
That's the same thing flopped around.
Yep, it is. That's the point. This is just traditional of saying y equals mx plus b. Now you use slope intercept. Is there an option to use point slope here, you think?
Possibly.
Yeah, I see some points.
I see some points, especially a good one at 1.5 and 2.9. So like you could have used any of those that you wanted. You just needed to recognize, hey, the slope, it's rising 4, it's running 1, right? Rising 4, running 1. Okay? So 4 times x. Now, if you're using that point, it'd be x minus 1 plus 5. If you're using 2.9, it would be 4 times x minus 2 plus 9. And all 4 of these equations are describing the same exact line, so they're equivalent. They would all work. But you need to recognize if I have a line, I'm using either point slope or slope intercept. Either way, you need to get slope. Okay?
Probably one got a 4.
The second one, it's more than the other one. How is it?
This one is?
Yeah.
Actually, notice this is the first term, which was 5. This is the second term, which is 9.
Oh, I was thinking it was the same term. The same
Because
one.
notice I'm using the 0.29 here and the 0.15 here.
Okay.
And remember, all of these are equivalent. If you distribute, you should get your slope intercept form. So 4x minus 8 plus 9. What is negative 8 plus 9?
1.
Hey, look, that's my slope intercept form. Right? Same thing will happen with the top one. That's how you know they're all equivalent. They're all describing the same thing, they just have different starting points.
Okay.
Yeah. Now g of x is a little bit trickier.
Yeah.
How would we approach g of x?
Man, I think I got this in the bag.
You got it in the bag?
Oh, okay.
What you got, McKay?
G of x equals 3. I'm gonna raise to the x times 1. Well, like not the x times 1, just times 1 in general. Yeah.
He wrote it.
Yeah.
He wrote it
Like that?
Yeah.
Okay. What do you think about that equation, Brayden?
I don't know.
I think it's really strong.
You think it's really strong?
Yeah.
No starting point. Wow.
McKay, when you look up here, where do you see your starting point?
3.
How are you getting a starting point of 3?
1.
Okay, because I would say, the way it looks to me over there is you're saying that your starting point is still 1. Is that true?
Yeah.
Now, I will say traditionally, you can put it here, that's fine. Traditionally, we'll put the 1 in front.
Dang it! That's what I had.
It doesn't, well, that doesn't matter, that doesn't affect it.
Because of that, you swapped that one up, so I just swapped the bottom one.
Oh, gotcha, yeah. So like, here's the thing, I want you to understand, this is still perfectly okay. This is just the traditional slope intercept, okay? And I actually usually like to write it this way because it mirrors this idea of an exponential better. Starting at 1, repeatedly adding 4. Here I'm starting at 1, repeatedly multiplying by 3.
Yeah, on my paper I have the 1 first, but since you swapped the first one up,
Yeah.
I might as well do the same thing.
Yeah, the only reason I swapped that up there is because that slope intercept.
Alright.
So Braden, where do you think McKay got that 3 raised to the x from?
I do not know right.
Oh, from, well, I got my 3 from the 9 up there.
What about the 9?
Because, the 9 is the second term,
Okay.
and
Gonna go with shaking
3
the desk.
times 3 is 9.
3 times 3 is 9?
Go with the desk.
By the way, I do want to remind you all of this. Are there any other mathematical representations I could have created to help me see this g of x more clearly? Say it again. The table.
He's like, that's
The reason why I bring this up is, I think with lines, we're pretty comfortable seeing slope pretty easily. But I feel like with an exponential, some people might want to go up 2 and to the right 1 and say, hey, I'm multiplying by 2. But actually, so x and g of x, when x was 0, g of x was 1. When x was 1, g of x was 3. When x was 2, g of x was 9. Now you can see it more clearly. What are we doing?
Multiplying by 3.
So I started at 1, and I'm multiplying by 3, and it's going to keep going forever. So to show that I'm repeatedly multiplying by 3, it's raised to the x.
I didn't even finish it. Hopefully.
Well, the x is more of a variable that can be any number. Let me point out though that you could have done effectively a point slope here, because I could have started with 3. And I'm still repeatedly multiplying by 3, but instead of just raised to the x, it'd be raised to the x minus
3.
Nope.
2.
Nope.
1.
3 was the first term, right? So it'd be x minus 1. If I started with the 9,
Minus 2.
minus 2. All three of those equations, they look different, but they are effectively the same. Okay? Does that make sense? Does that help us be better prepared for next week, hopefully? Know how to do slope intercept and all that? So you have a review homework in front of you. It is 30 questions. It covers all the stuff on linear and exponential functions. The only thing that it does not have
The roots.
is roots. And you'll see there's a note at the bottom for roots, see the task and understanding checks. Because on this understanding check, bless you,
Roll top.
numbers 10 through 15, we did not do yet.
Oh god.
So that's your practice for roots. It is your turn to do what you want for the rest of class. I'm here to support you and help you learn. Y'all can talk with each other to help each other, whatever you want. But what I do require is that you do something productive to help get ready for the test next week. I would recommend, well, first off, let me say this. The review homework will be due next Friday. Okay? However, I would do as much of it as possible before Monday, so that on Monday, our last day of review before the test, you can ask the questions of, hey, this is what I'm struggling with.
Yeah.
Yes, McKay?
What are the exams Friday?
Great question. Your exam for me is on Wednesday.
I have
Alright,
to schedule.
So if it's due Friday, could I give it to you before?
It's due Friday. You can give it to me any day before.
Because as soon as I'm done my last exam, I'm out.
I get it. I'm letting y'all have the latest due date possible, but you can turn it in as early as you want. But I would make sure it's done well.